In this video, I want to look at a number of problems involving arc length. These are going to be problems involving three quantities: length of the radius, angle measure, and the arc length formed by that rotation. Sometimes the angle measure is in radians, sometimes the angle measure is in degrees. So first problem. Suppose we have a radius of 9 centimeters and an angle of pi over 2 radians. What is the arc length? Well, to handle this problem, we can just think back to our definition for radians and recall that one of the formulations is that if we take our measure in radians, multiply by the radius, we get the arc length. So for this problem, just take your pi over 2 radians, multiply by your radius, and your arc length pops out 9 pi over 2. Let's look at a similar problem, but this time, what if our rotation is given to us in degrees? Well, one thing that we can do is we can start by converting our degree measure to radian measure. So let's do that. As we saw in previous videos, to convert to radians, we want to multiply by radians over degrees, and one ratio that we can use is pi radians to 180 degrees. So this is 100 over 1, just multiplying fractions. Let's do some canceling. 20 goes into 100 5 times. It goes into 180 9 times. So this angle in radians is 5 pi over 9. So my arc length is the radian measure times my radius we're going to get 5 pi centimeters. So that was problem 2. Let's look at problem 3 and also 4. Three, we change things up a little bit. We're given the radius and the arc length, and we want to know our angle theta. So let's do this in two parts. Suppose we want to know the radian measure of theta. Well, think back to our definitions for radians. We know that the radian measure is just the arc length divided by the radius. So our radian measure here is just 6 over 16 equal to 3/8 of a radian. What if I wanted to know my angle measure in degrees? Well, one angle of attack that we can take is to figure out our measure in radians and then convert it to degrees. We've already figured out the radians. To convert to degrees, I want degrees on top, radians on the bottom, pi radians in 180 degrees. So we're multiplying fractions again. Let's see here. 4 goes into 8 twice, goes into 180. Wait, let's back up. Let's do it by 2s. 2 goes into 8 4 times, into 80 90 times. 2 goes into 4 twice, into 90 45 times. So here we are going to get 135 over pi degrees. So 3/8 of a radian is the same thing as 135 over pi degrees. And that is going to be the angle measure with this radius and this arc length.